Welcome to Endpoint Math with Mr. White. You are in for a treat today because we're going to be looking at the graph of the tangent curve, the tangent function. We're going to take a look and find the asymptotes. So the tangent curve has two vertical asymptotes, sine and cosine. In my other two videos you learned do not have any asymptotes, of course, but tangent does. So we're going to find two asymptotes, but then only 3 points. So we do have to find 5 things, just like we did with sine and cosine. But this time with tangent, it's 2 asymptotes and 3 points. So let's dig into the first example. This is my plain vanilla example, just like with sine and cosine, where we want to graph tangent without any transformations at all. So let's talk a little bit about tangent. The tangent curve has a period of, do you know what it is? I bet you went over it with your teacher. It is only 1 pi. So sine and cosine had a 2 pi period, all the way around the unit circle. As it turns out, tangent is only 1 pi period. So that's a little bit different. There is no amplitude. There is no such thing as amplitude. We can talk about vertical stretch of this thing, and we will, but there is no amplitude, okay? So let's get to this. Tangent has 2 asymptotes, and they're on either side of 0. So the tangent curves goes through 0, 0 normally. Just like sine starts at 0, 0, tangent goes through 0, 0. All right? However, we are going to go a half of a pi this way. So I'm labeling that pi over 2. And then we're going to go a half of a pi in the other direction. So this is negative pi over 2. And that's where our vertical asymptotes go. So I'm going to put some dotted lines there. I would encourage you to do this on your own graphs of tangent to show that there's vertical asymptotes there. Now, do you remember that the tangent of 45 degrees, the tangent of pi over 4 is 1. So we go over pi over 4, this is pi over 4, and we go up 1. And then we go back pi over 4 and we go down 1 because the tangent of, let's see, what would that be? 135 degrees is negative 1. All right, so the tangent of negative, I'm sorry, I misspoke. So the tangent of 315 degrees, there we go. That would be negative pi over 4. Negative 45 degrees is negative 1. All right, so we've got our 5 things. Let's count them. 1, 2 asymptotes, and then 1, 2, 3. 3 dots. This is all we need. And we graph it. Here we go. So this thing gets really close, comes down, and then it cuts through the origin at a 45-degree angle. It does not go horizontal like x to the third, right? X to the third would look like that. That was an x to the third. It would go horizontal for a moment. Tangent does not do that, folks. Tangent actually cuts through at a 45. So do a nice job graphing, and then it gets really close there. So there's 1 period of tangent. And notice how it is 1 pi. It's a half on this side and another half on that. Makes a total of 1 pi in length. Okay, and then just like these other periodic functions, this thing continues to repeat. So on my graph, it would be 4 blocks is the equivalent of 1 pi, and this thing would just keep going like that. So I'd put a dot here, and then I could put my other 2, and then quickly graph more periods of tangent. And of course, it goes over here also. You don't need me to do 1,000 of these, but it goes down like this. Tangent is what we call an increasing function because on its domain, it just is always going up, 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 left to right. So it's increasing. All right. So let's take a look at a few transformations. So the -2, that's an easy one. That just does what to any graph? It moves it down. This is down by 2. So it's a vertical translation or vertical shift by 2. So I'm going to go down to -2. And if you want, to put a midline there, I guess you could. That's fine. And then just like the last problem, we're going to go pi over 2 this way and negative pi over 2 this way and put our asymptotes in there. There's our asymptotes. We're going to get really close to that, but never actually touch it. Then I put my big fat middle dot right there, because it used to be up here, but I've moved it down by 2, right? Now there is no vertical stretch, so it will be exactly the same shape as the previous slide. It's just moved down. And then you could rinse and repeat over here. Okay? So there's another period. So that's tangent x minus 2. That was easy, right? All right, let's see what other goodies we have. All right, what does a 2 out front do to these graphs? Well, that is it used to be amplitude, right? That made the sine curve go as high as 2, low as negative 2. Well, tangent doesn't have amplitude, but it can be stretched, of course. So this one still goes through 0, 0. It still has a period of 1 pi. So I'm going to go pi over 2 this way. I'm going to go negative pi over 2 this way and put my dotted lines. Those are my asymptotes. But what do you think the 2 does? So let's look at a t-chart. At pi over 4, it used to output 1, right? When we had our x and then we had tangent, we had 1. Well, what would 2 times that be? It would just be 2 times bigger. You see what I mean by that? That 2 just makes all the outputs 2 times bigger. It used to be 1. Now it's 2 times bigger. It's 2. So I put my dot here and here. I've got my 5 things, my 2 asymptotes and my 3 dots. I'm good to go. And there it is. So this one does not cut through at a 45. You could probably take the time to figure out what that angle is. We're not going to do that in this video. And here, I'll graph one more period of tangent. All right, so that was our vertical stretch. Okay. We've got 4 more examples with different things. So make sure you watch all the examples, because I tried to not repeat a lot, but we want to go through all the different twists and turns that your teacher could throw at you. Tangent of 4x. So now this is on the inside. This is on the inside. So this affects the period. Okay, it affects the period this time. So just like with sine and cosine, what I always taught my students was to say 4 times x, when does that finish? When does it come out to be pi? You set up that little equation, you divide by 4, you get at pi over 4 is the period. This is the period. So what does that mean for our graph here? That means this time we're going to go over an eighth on each side. An eighth on that side and an eighth on that side. Because what is half of a quarter? Half of a quarter, if you divide a quarter in half, it's an eighth. You knew that. All right, so that's where my asymptotes are. I have the luxury of my graph paper that I don't have to cram things too tightly here. And there is no vertical stretch. So once again, 1, 1, 1, 1. So really, this is a horizontal shrink. This entire graph is 4 times faster. That's what that does in there. Often when I say that to students, their eyes pop open and they're, oh, I get it now. That 4 makes the graph cycle 4 times faster. So what used to take a full pi to happen now only happens in a fourth of the time, pi over 4. All right, so then we can go another pi over 4. So that would be I got to go 4 blocks, of course. All right, this would be 3 pi over 8. That's another quarter. 2/8 is a quarter. And we draw an asymptote here. And I've got boom, boom, boom. And there's my graph. Easy peasy, right? All right, so there's tangent, and that one's been compressed by a factor of 4. Uh-oh, now we got 2 things going on. What are the 2 things? Well, there's a minus out front. You know what that does? We're going to flip this graph over. It's going to be a decreasing. It's going to be decreasing. It's going to be a downhill roller coaster now. So it's going to be reflection. So we know that it's going to be decreasing or downhill now. And this time it's divide by 3. The last one was multiply by 4. So you know what this is going to do? This is going to be a major drag. It's going to slow down the period by a factor of 3. So it's going to be 3 times shorter. So again, what I often tell students, if you have troubles figuring it out, you can always say, when is this pi? And then if you multiply by 3 on both sides, you see it happens after 3 pi. So we're going to have to go. So if this is pi here, this would be half of a pi, right? Here's negative 1/2. So this is, I'm setting this up just like the first graph as far as how I'm labeling my x-axis. But wait, if I split this in half, that's 1.5 pi. That's 3 pi over 2. Uh-oh, so I have to go further. Okay, so here's 3 pi over 2. And over here is negative 3 pi over 2. I have to put my negative sign there. So this thing truly is slow as heck here. All right, and then slow as heck over here. Okay, so this is a horizontal stretch. All right, so this thing still goes through 0, 0. But remember, it's going to be going down this time. But we need to get those other dots. Those other 2 dots. So where do they go? You might want to pause the video and think about this for a second. Where do they go? Well, I have to go in the middle of this right here. There's the middle. All right, let me get rid of that now. Here's the middle, and I'm going to go up to right here. I'm going to go over, and I'm going to go down here. There's negative 1, and there's 1. So now I can graph the curve itself. It goes through here, and then it goes down like that. So that's one period of negative tangent. This is decreasing, and it was 3 times slower than normal. Normally it would have fit in this region here, but this is actually 3 times bigger. All right, we have 2 more examples. So we haven't done one like this yet. We know what this does. That's a vertical stretch, right? It's going to be 3 times steeper. So that's no big deal. But what happens when you throw a number in there? This is a shift left by pi. Now the period is still 1 pi. That doesn't change. But we are going to stretch this by a factor of 3. So I used to have my center point there. So I'm going to have to go to the left by pi over 2. So here's negative pi over 2. Here's negative pi. Here's negative pi. I'm sorry, 3 pi over 2. Here's pi over 2. And here's pi. Okay, so we used to be here. I have to move that point to the left by pi over 2. Then around there is where I've got to go figure out my asymptotes. So I go a pi over 2 to the right. That's this distance right here. That's pi over 2. And then I'm going to go pi over 2, a half of a pi this way as well. So I get an asymptote here. So this time my asymptotes are here and here. Now remember, normally my dot would be right there, but this is 3 times higher, so I go up here, and I go down here. And we've got our tangent curve. It's very steep. It's been moved over a little bit, as you saw. And this is an increasing function. And we could keep graphing. So there's 2 periods of tangent. All right, last problem. This one's a bit tricky. What's different here? Well, we got a number out front here, and we have the number there. And we're shifted down by 2. So we shift down, by, sorry, I misspoke, by 1. That's due to this guy right here. All right, so inside, you have to factor this. You have to divide out the 1/2. And I did this on purpose because a lot of students freak out about the fractions. So we're going to divide 1/2 out, and we get x plus what? Well, if you're not sure, you can always go to some scratch paper and do this. I'm starting with pi over 2, and I'm dividing out 1/2. So because of keep, change, flip, you end up multiplying by 2 over 1, right? And if you multiply straight across, you get pi, 1 pi. So this would be pi there. You can always check your work because 1/2 times pi does equal 1/2 of pi. So that makes sense. All right, so now we see this is left by pi. And we have to figure out the period. All right, so there's a lot to figure out here. The period, we write 1/2 x equals pi, so x equals 2 pi. All right, oh my goodness. So let's divide, oops, I didn't mean to do that. Let's do this. Let's call this pi. This will be 1/2 of a pi, just like before. I tried to find some graph paper that would be helpful in showing you all the different ways you could graph this. This would be negative 3 pi over 2. This would be negative 2 pi. All right, so let me draw the new midline here too. This is the middle down here, because remember it was shifted down. All right, so I'm shifting, it used to be here, I'm shifting down by 1, and then I have to go to the left by pi. So that puts my center dot right here. So I went down by 1, and then I went to the left by pi. All right, now the period, how wide is it again? The period is 2 pi. So I'm at negative pi, so I got to go a pi in either direction, right? So that would put me out here. So let me draw my asymptotes. Here's my, oops. Here's my asymptotes, like that. And then I come over here to right here. You see how if we got our ruler out, this measures 2 pi in length. All right, so in bright pink there, I did that center dot. Now we don't have any vertical stretch, right? So I go to the middle on each side, and I go up or down 1, just 1. See how I did that? This one's tricky, right? So let's go through all the different things. We shifted down by 1. We did our left by pi. And we also worked it out so that it had a period of 2 pi. There was no vertical stretch on this one. All right, and here's our graph of 1 period of tangent. All right, that wasn't so bad, right? All right, well, hopefully you found this video useful. Tangent is just one of those 3 trig functions that your teacher's going to want you to know. So hopefully you feel like an expert now. Tackle that homework, and we will see you next time. Good luck.